so this is today's weather forecast. So I went to weather.com and I got the weather forecast. And it said that today, February 22nd, it's partly cloudy. If you go outside, you can see that there are sun clouds. And it said that there's a 20% chance of rain. A 20% chance. Why do they say a 20% chance? Why don't they just say it won't rain? Or it will rain?
I think about it, but we generally use not 20% chance. We generally use 20% probability.
A 20% probability. Probability and chance are related concepts. Probability has to do with chance. So in some sense, they're basically synonymous. It means they're often used in the same way. So if instead of saying chance, we say there's a 20% probability, what does that mean? Why do we say that instead of like, oh, it's not going to rain today, or it will rain today? Right? Because there is truth. At the end of the day, it will either have rained or it will not have rained. Does that make sense? So there's some truth. So why can't we say yes, it will rain today, or no, it's not going to? Pardon? We don't know for sure. We're not 100% certain of what the truth actually is, right? So lots of times people talk about chance and probability. So these are scientists that are doing this, meteorologists, right? Meteorologists study the weather. But they're wishy-washy. They're not telling us, today it's going to rain, bring your umbrella. Tomorrow it's not going to rain, don't bring your umbrella. They say there's a 20% chance or 20% probability of rain. So figure out for yourself whether or not you want to bring your umbrella. Okay, so on the weather.com, they actually have a link that if you click it, it tells you what chance means. So it says the chance of precipitation describes the likelihood of precipitation, that means rain, maybe not even measurable in your forecast area. The chance is based upon a series of instances of identical weather conditions. For example, a 40% chance of precipitation means that precipitation occurred 40 out of 100 days with the same conditions expected in your area, right? So under identical weather conditions, they had rain on 20 of the 100 days. Does that make sense? And I actually have a problem with this. If the conditions were really identical, what should have happened? Say what? That's right. If the conditions were truly identical, then it would always have rained or always not have rained when the conditions were like this. So when they're saying identical, they don't really mean identical, but what do they mean instead?
Same in some. It's the same, but it's not identical. But
It's the same, but it's not identical. Is there another word that sort of expresses that idea? Yeah, it's similar. With very similar conditions. When you have one mass of air coming from one direction that's one temperature and it has so much humidity, and you have another mass of air coming from a different direction with a different amount of humidity and a different temperature, right? Under those conditions, you see rain 20% of the time. But there are differences, right? Sometimes you have a little bit more cold, sometimes it's a little bit warmer, a little more humid, less humid. The direction of the wind might change, right? So there are lots of things that make it not identical, but make it similar. So really, they're not talking about identical instances. They're talking about very similar instances. So really, the scientists, they don't know if it's going to rain or not, unless, you know, it's raining and they look out the window and say, oh yeah, it's raining right now. 100% chance. Okay, there's not just this, you know, hesitation to say it's going to be this or it's going to be that. In meteorology, it happens in psychology too. So this is from an article that's talking about major depressive disorder and some ways to treat it. And one of the things they say, although relapse or recurrence may be prevented with long-term pharmacotherapy, so that means if you take the right drugs, you might avoid a relapse, right? They say may be prevented. Why don't they say will be prevented, right? May suggests that there's this probability that they don't really know for sure if it will be prevented with you or if it will be prevented with you or anyone else, right? Here's another one. This approach is recommended only for patients at high risk of relapse. At high risk of relapse, why don't they say is only recommended for patients who will relapse? Same thing? Can you? Yeah, they're not certain who's going to relapse or not, right? The three of you might look like you're going to relapse, but only two of you might relapse. Only one of you might, none of you might, right? So we're not certain who's going to relapse. Here's another instance. Alone or combined with medication has been shown to be effective. Has been shown to be? Why not is? Again, same kind of idea, right? In the past, there have been instances where this has occurred, but not all the time. And even if it did occur every time, we can't be completely certain that some new observation won't contradict with the ideas that we've seen in the past. Does that make sense? So, as we talked about truth last time, we said that we really can't fully know the truth. I asked you guys, so can you know if your mother loves you? And I said, no. And when I say that, I don't mean no in the colloquial sense of the word, meaning like, we believe something to be true and it seems very likely to be true, so we know it. I'm talking about the scientific type of knowing, 100% knowing, which isn't possible with this type of stuff. So here's another example. Juvenile delinquency and adult criminality. According to National Institute of Justice study, abused or neglected children were 11 times more likely to be arrested for criminal behavior. So this is saying that abused kids are more likely to become criminals, right? So let's assume that this is actually correct, that abuse leads to crime. But why do we have this? They were 11 times more likely. Why don't we just say that, abused kids become criminals? Yeah, again, the same thing. Some of them might be, some of them might not be. So why don't all of them become criminals?
Individual differences.
Individual differences, such as what?
Personality.
So there might be some personality differences, right? So people talk about the difference between introverts and extroverts. And what do introverts like to do on the weekends? Stereotypically.
Reading.
They like to stay at home and read, watch movies, or do something. And what do the extroverts like to do? They like to go out and do things with friends and stuff, right? So who's going to have more opportunities to commit crimes? The person who is reading at home, or the person who's out walking about on the streets? The person who's the extrovert might have more opportunities to commit crime. If you have more opportunities, you might do it more, right? So there could be some personality differences. What else might lead to some differences in determining which abused kids or which not abused kids become criminals? Yeah?
Environment.
Environment. Like, how so?
His or her friends, which are commit crime.
Okay, so, like, I remember when I was a kid, I had some friends that my parents didn't like me to hang out with. This one guy, we would build these little, like, matchstick bombs together and blow them up in his backyard. Cut off the heads of matches. Boom! Just fun stuff. But my parents, they're like, oh, this, kid, you don't want to hang around with him. But then I had other friends who we didn't do things like that. We would, play ping pong or, tag, other games that didn't involve explosives. So, depending on the friends you have, your friends might, if they are more criminally oriented themselves, they might convince you to commit crime. Whereas if you have friends who don't want to engage in those things, maybe not so much. Does that make sense? So the friends could affect it. What else could affect it? The family. How could the family affect it?
If your father or your mother do not like or love you, or they do not show your the relation between them is sometimes weak, sometimes strong. That can be.
Yeah, so I mean, there's some problems with the relationship already because they're getting abused, but there still might be some other differences that's present in the family, right? So you might have a parent who abuses you, but is also telling you, you know, don't go out and commit crime, this is wrong, you shouldn't do this, you shouldn't do that, when they're not abusing you. And you might have other parents who abuse you sometimes, and they're just like, whatever, you can do what you want, right? So differences in discipline. So lots and lots of things are sort of left up in the air. They're left up to chance. Are you born into a family where your parents are disciplined? Are you born into an area that's poor? So maybe if you're abused and you're in a poor neighborhood where you don't have a lot of resources, you might be more likely to go and steal than if you're abused in a rich neighborhood and you have everything that you need, right? So you can't determine where you're born or who you're born to, so these things are left up to chance. Socioeconomic status, positive role models, personality differences, different types of parents, lots and lots of stuff. This makes prediction difficult enough for groups, but even more so for individuals. Because over groups, a lot of this stuff that's left up to chance sort of washes out. If I get a large enough group, there might be some of you who came from very poor families, but there are also going to be some of you probably who are from very rich families. Does that make sense? So if we look at a group, some of those differences sort of even out statistically. But even with groups, prediction can be difficult sometimes. All right, so let's talk a little bit about parapsychology. Remember, I think it was the first lecture of class where I said that psychologists are interested in basically anything that humans can do, in some things that humans can't do. Parapsychology fits in here. What is parapsychology?
Crazy psychology.
I wouldn't say crazy psychology. What does para mean? A paramedic, a paralegal.
Yes, the behaviors that we cannot do physically.
Okay, so the psychology is the scientific study of the mind, and science is based on the assumption of natural explanations. And para, what it means is around. So the things that are around the natural explanations would be like supernatural explanations, right? So it's things that are related to psychology, abilities that people may or may not have, that don't have these sort of natural explanations for them, right? So if you think about a paralegal, what a paralegal does is they work with lawyers, right? And they don't actually go into the courts and try cases and things, but they work around the lawyers. The paramedics, they're not doctors, but they work alongside, they work around the doctors to help people make it to the hospital in time. Does that make sense? Okay, so things like extrasensory perception. Are you psychic? Can you move things with your mind? Can I move the pen? Actually, I can move the pen with my mind. You want to see me? This is kind of cool.
Yeah.
All right. Okay, I'm sending a signal from my mind to my arm to pick up the pen, and I moved it with my mind. Okay, so let's look at some parapsychology. Are you psychic? Is anyone in here psychic? You guys took chickens? Pardon?
What does it mean, really psychic?
What does it mean if someone's psychic?
Basically, I don't know.
Scope up.
So my wife and I, we went to someone's house for dinner, and they had these cards, and then my wife picked out like 5 of them, and then this lady read her future. She's like, oh, okay, this good thing is going to happen, and this is right? This is psychic. Psychic has something to do with maybe telling the future. Fortune telling. What else? My daughter likes to play this game. She says, which hand has a penny? Which hand has a penny? Is it my left hand or my right hand? It's my right hand. That's which. Yeah, it's when you have the ability to detect something that you shouldn't have the ability to detect, right? Whether it's detecting the future or detecting which hand has a penny, or in this case, a lira. Oh, please. Okay. Okay, so we're going to test if you guys are psychic. If you guys took Chetin's Understanding Science and Technology class and you were there for my day when we did this, you're going to get a repeat. But what's the probability that you would correctly guess the result of a coin flip if you're not psychic? 50%, right? If you guys aren't psychic, you should get the coin flip 50% of the time. Why is this? There's only heads or tails, right? And what guesses could you make? Assuming that it doesn't land, you know, like that. If it doesn't land on its edge, what are the two outcomes? It's going to be heads or tails, and your guesses are going to be true or false. Heads or tails, and it's going to either be true or false. This is what's known as an outcomes matrix. In high school, if you took a biology class and you talked about Mendelian genetics and how the genes get passed on, you may have used something like this. It may have been called something different. In biology, it's often referred to as a Punnett square. But this is really an outcomes matrix. So the coin, there are two possibilities. The coin can come up either heads or it can come up tails. And you have two things that you can guess. You can guess it's either going to be heads or it's going to be tails. So if we look at the outcomes for the different possibilities, we see that if we guess heads and it's heads, we got it right. If we guess tails and it's tails, we got it right. If we guess tails and it's if we guess heads and it's tails, we're wrong. And if we guess tails and it's heads, we're wrong, right? So now we can look. Out of all these events that could potentially happen, how many of them are we right on? Well, we're right 2 out of 4 of the times, which is 50% of the time. We're wrong 2 out of 4 of the time, so we're wrong 50% of the time. So there are 2 correct outcomes out of 4 possible, so there's a 50% probability of getting it right if you're not psychic. Right? So, in a little bit we're going to test your psychic abilities, but first there are some other things I'd like you to talk about. So I want you to put on your signal detection goggles. So imagine that we're only interested in heads, right? Heads, the presence of heads is some signal, right? If heads is up, it's sending out a signal that heads is up. And if I'm looking at it, I can detect the signal, right? So I am detecting the signal of heads. But sometimes there's noise. What is noise? You guys hear the noise? So this is buzzing ever so slightly. My voice is a signal, right? And if this noise is loud enough, what's going to happen?
Distracts.
It's going to make it hard for you to detect the signal, right? Now, so there's a signal. It's heads. I can put my hand over it. There's noise over this signal. Or even for those of you in the back of the room, if I flip it, I don't need to cover it because the signal, you probably don't have supervision, right? So you might not know, you might not be able to detect the signal. So imagine that we're only interested in heads. You guys get the joke? This is a psychology class. We're interested in heads. Okay, so we can create an outcomes matrix, right? So we're only interested in heads. Did the coin turn up heads or not? Yes or no? Did you guess heads or not? Yes or no? And again, we have the same distribution of correct and incorrect responses. However, we're going to call them something a little bit different when we're talking about things in a signal detection framework. So if it is a heads, and if you guessed that it was a heads, we call this a hit. It's like if you're playing baseball, right? You swing the bat, and when you're swinging the bat, you're saying that the ball is here. And if the ball really is there, you hit it. You get a hit, right? Good. If it's not a heads, and if you didn't guess heads, this is called a correct rejection. Because you correctly rejected the notion that there was a heads there. If we're talking about baseball, this would be like, in baseball there's a certain area that the ball is supposed to go, and if it doesn't go in that area, you're not supposed to swing. So if the ball goes outside of that area and you don't swing, you correctly rejected that it wasn't in there. Does that make sense? All right, now if you say that there's a head there, but it's wrong, this is called a false alarm. Now, false alarms, I think it's easier to talk about real alarms.
Isn't that miss?
Pardon?
Isn't that miss?
No, because there was no head, so there was nothing you could have missed. Does that make sense? It wasn't there. You didn't miss it. In fact, you said that there was something there, right? So you didn't miss it. What you did is you made a false alarm. You said that something was there when it wasn't. So think about a fire. If there's a fire, what should you do? You should get out of here. But if there's an alarm, what should you do? You should pull the alarm. Did you guys at school ever have instances where someone would pull the alarm and then you would all go outside but there was no fire? That's a false alarm, right? It wasn't a real alarm, it was a false alarm. Cool? All right, so imagine that the fire is there and we don't realize it. So there are some people who can't feel pain. Some neurological problem that doesn't allow them to feel pain. And this might sound great because it means if someone punches you in the face, you can just stand there and go like, ha, ha, ha. But it's bad because when you're cooking or doing things, if you touch a hot pan and you can feel pain, what will you do? You move your hand away. But if you can't feel the pain, what will you do? You're going to burn yourself. This is also a pretty bad thing. This is a miss. There's something there, but you missed it. So in baseball, the ball was right here, but you didn't swing. You didn't put your bat right there. You missed it. Okay? All right, so we have these different types of outcomes that we refer to as hits, misses, false alarms, incorrect rejection, and signal detection. Now, this allows us to be more precise when we talk about the things that happen. Before, when I had the outcomes matrix, I basically said correct or wrong, right? We had two ways to describe things. Now we can describe things better, right? Okay, they were wrong, but how were they wrong? Did they miss something? Or did they make a false alarm, right? The basic idea behind signal detection, this is really important. It underlies perceptual research, research on biases, research on sensitivity, and almost all of the traditional statistics. Okay, so a little bit more signal detection. What is bias? What does that mean if you're biased? Laura, can you tell me what bias is?
It is I think, preconjunction. You shouldn't say something before the situation, but because it's a negative thing. But if you say this will be effective on the results. Not like that, but preconjunction, I think.
I'm not sure I completely follow that. So if you say something that's sort of negative, like Dr. Knapp is a jerk. This is kind of negative. That would suggest that you're biased, right? You're biased what? Towards me or against me? You're biased against me. I might really be a jerk, right? But bias is going to say, how much you're pushed in one way or another. Did you have something?
Yeah, it's like when you're more responsive to one other than the other.
It's not when you're more responsive to one or another. We're going to get to that in just a second. That's not what bias is.
Bias is not being fair and favoring one group of people over.
Yeah, that's exactly right. Did everyone hear her? Bias is when you're not being fair. When you're favoring one group or another. So, imagine that Nadia was flipping, okay, we'll just imagine it. She's flipping a coin, right? And I'm blindfolded. And I'm supposed to guess whether or not it was heads or tails. We're going to see if I'm psychic. So if I really can't tell if there's a head or a tail, if I can tell, I'll say heads when it's heads and tails when it's not, right? But if I can't tell, I'm just going to be guessing. So I might be biased to guess yes, or I might be biased to guess no, right? If I'm extremely biased to say no, what will I say every time she flips? I'll say no every single time, right? If I'm extremely biased to saying yes, what will I do every time? I'll say yes every time. If I'm not biased at all, I should say it'll be heads 50% of the time and tails 50% of the time. Does that make sense? So, bias is a tendency to respond one way.
Oh, isn't this what I just
So, what?
I said you are more responsive to one as more than the other.
But this is different. It's different. So you're saying when you're more responsive to one thing than the other?
Yeah, if you prefer one, you respond to one more than the other.
Ah, okay. Because when you said you respond more to one than the other, like I was thinking like this means that you're able to tell the difference. So I'm responding more, but you were thinking of it in a biased way. Okay, so it's a tendency to respond one way. No, I think when you said originally you're responsive to, what's out there, something like that, or at least that's what my interpretation was. Right? If you're responsive to what's out there, that means you have some ability to detect what this is. Yeah, if it's a tendency to respond in one way, this is exactly right. So imagine that we're in Turkey, and we have a business, and we want to hire an employee for something. I don't know, account manager. And we have people come in and interview for the position, right? Maybe we have lots of positions, lots of account manager positions open. And I have lots of people coming in and applying. So if I'm biased towards people with a headscarf or without a headscarf, what might happen?
It will be unfair.
It will be unfair. I won't be looking necessarily at the qualifications, but I'll be looking at something else. So you are eminently qualified. You did so well in college, but you're wearing a headscarf, and sorry, I don't like it. You're not going to get the job. Right? That's a bias. I am biased against hiring people with headscarves. Or maybe the opposite. I want to have headscarf people in my business, so I'm going to hire them. Sorry, Baileys, you're very well qualified, but I want women who are wearing a headscarf because modesty is really important after all. Right? So, sensitivity. This is what I thought you were saying, but you weren't. What's sensitivity? And this. What's sensitivity? If you were sensitive to your readings last night, should you get this answer right or wrong? If you were sensitive to the information in the readings last night, you should hopefully get this right. Right? What does it mean, sensitive? May I touch you? Okay, I want you to close your eyes, okay? Did you feel anything?
No.
I touched him, right? You didn't feel it.
Okay.
Okay, he got it, right? This has to do with sensitivity. He was able to feel it when I pressed him hard enough, but he wasn't able to feel it when I touched his shirt very lightly, right? So sensitivity has to do with how sensitive you are to the signal, right? If you're very, very sensitive, like I'm very sensitive to whether this is heads or tails because I can see it right here. Those of you in the back, probably not very sensitive. Can you tell what this is? No, she can't tell, and come on, that face is right to you. Right? She's not sensitive to the signal. There's a signal there, but she's not sensitive to it. Yeah.
Is it about physical things? It's not about emotional.
It could be physical, it could be emotional. So,
You said signals, so it's physical.
right, but
She can't see it. That's why she cannot, and I cannot see it too.
But emotions, when people have emotions, they send off physical signals. I'll give you an example. Oh dear, I forgot your name. What was your name? Zeynep. I should have guessed that. Zainab, I want you to tell me what type of emotion I'm displaying, okay? I'm sad, right? There's an emotion. She was sensitive to it, okay? I mean, if I just keep my face still, you know, I might be sad, I might be happy, I might not be able to tell. But lots of the times when people have emotions, we send off signals. This is why when we talk about love, right, we don't know if you love me or if you hate me or whatever, but based on the signals that you send to me, I can get an idea. I have an idea about who's bored and who's having a good time in this class based on the signals, based on whether you're sitting there like this or whether you're sitting there like, right? I'm getting some signal. So sensitivity has to do with your ability to detect the signal. When he said responsive initially, I was thinking your responsivity. If you're responsive to the signal or not. He wasn't responsive when I touched him lightly. When I poked him hard, he was responsive. If I poked him hard enough, he'll be very responsive. Ouch! Okay, so hiring. If I want to hire someone for my business, what should I be sensitive to? Good potential. How do we measure good potential? This is really difficult. I mean, their qualifications, they did well in college. Does that mean they're going to be a good employee? Maybe. I would say that increases the chances that they'll be a good employee because they worked hard when they were in college, probably. Either that or they just got lucky, you know, a lot. But I would say that, you know, GPA and some things like this indicate potential, maybe not perfectly. We could use converging methods to look at a lot of different indicators of good potential. Not only do we want your grades, we want reference letters, right? Okay. So let's go back to the weather real quickly. There was, when I was in, my first 2 years of college, I went to Millikan University, which is a small liberal arts college. And there was this student who would carry an umbrella with him every single day. Every single day he had his umbrella. How sensitive was he to whether it was raining or not? Very sensitive?
No.
I would say he probably wasn't very sensitive. It's possible that he could have been sensitive, but something was overpowering his sensitivity. What was overpowering his sensitivity if he were sensitive? What's the other thing up there?
Bias.
His bias. He was biased to always carry the umbrella. If you're sensitive to the weather conditions, and you don't like rain, you'll carry an umbrella on the days that it's likely to rain. And you might be biased. You might really hate the rain. So in this situation, when you're not sure if it's going to rain or not, what are you going to probably do? You bring the umbrella if you really don't like the rain, right? If you don't care so much to get a little wet, what's going to happen? You might be biased in the other way. I'm reasonably sensitive to whether it's going to rain or not, but I'm very biased. I hate carrying an umbrella. I hate it. I like not getting rained on, but, oh. I'm lazy. Okay, so what is bias affected by?
Passion.
Maybe passion towards something that could stem from lots of things, your parents, past experiences.
Prejudice.
So maybe I've hired some people in the past and I've noticed that the Bushutlu women work harder than the Bushutusus. So when I'm hiring in the future, I might be more biased to pick Bushutlu, right? So past experience could affect this. What else?
Trauma.
Trauma, maybe. Imagine that you're a doctor and you have a medication that is supposed to, like, cure cancer. And someone comes to you and they say, you know, doctor, I think I have cancer. And you run some tests. And you're not sure. You know, it's like, well, there's some things that suggest they might have cancer, but there are other things that suggest there's no cancer at all, there's no problem. What do you do? If it's possible that they have cancer,
Yeah.
you might want to give it to them anyway, right? So, depending on the expected outcomes of what might happen if you respond in one way versus another way, this is going to change potentially what you do. Right? Imagine that there's a fire alarm at your school, and anytime you smell smoke, you know, you're sensitive to smoke, and you want to pull the fire alarm. Now imagine different situations. If one time, and you pull the fire alarm and there's no fire there, then people are like, well, good job. You know, we want to know when there's a fire, so good job for, you know, being alert, even though there wasn't anything this time. Versus a different situation where they say, there was no fire, you're kicked out of school for 2 weeks. Right? Is this going to affect your likelihood to pull a fire alarm? Yeah, absolutely. So this is affected by risks of potential decisions, whether someone might die based on how you respond or not. It's based on the rewards.
Penalty.
Yeah, penalties, rewards, personal preferences, handedness, and lots of the research that I do. I have people make yes or no decisions, and I have them indicate yes with one hand and no with another hand. This could be a problem. Why? And I look at how fast they respond. Right? Why might this be a problem? If I use my right often more often, if I use my right hand more often, my right hand should be a little bit faster potentially, so I might be faster to respond with the right hand than I am with the left hand, right? This is a bias. So biases can come about from a number of things. How about sensitivity? What affects sensitivity? I already sort of suggested some of this. Distance, which is, can anyone give me something else that I've referred to earlier?
Noise.
Noise, right? So there's a lot more noise in the signal to you than there is to him, based on the distance, right? So the noise that's present. What else? What if this were like this big?
Size.
Yeah, so if we don't just think about size, if we think about the strength or the salience, meaning how obvious the signal is, right? So if I'm yelling, it's not going to matter if this is a bit more noisy, right? But if I speak quietly, the noise is going to affect you a lot more. So this is affected by stimulus salience. It's affected by attention. If you're tired, you're not going to be able to pay as much attention, which is going to make it harder for you to detect some signals. And environmental noise. Bias and sensitivity are independent from one another. What does this mean? They're independent. Yeah, it means that you could be completely biased and not at all sensitive, or completely biased but very sensitive, or the opposite, right? Not biased at all and not sensitive at all, not biased at all and completely sensitive, right? So you can get any combination of these. They're independent from one another. So the question is, with this psychic thing, is are you biased or sensitive? But there's one more thing to consider when we're doing science, and that is the null hypothesis. What's the null hypothesis? Opposite of what?
Hypothesis.
It's opposite of the alternative hypothesis, or
Invalid if an hypothesis states that something will happen. The opposite one, the invalid hypothesis.
Right, so the hypothesis, if my hypothesis is that Nadia is psychic, the null hypothesis is that Nadia is not psychic, right? So it's a statement of no effect. Abuse doesn't cause delinquency, right? Earlier we made the assumption that it does, but the null hypothesis is that abuse doesn't affect or cause delinquency. The processing doesn't matter, right? That you are not biased, that you are not psychic, that you are not sweet, that you are not smart, that you are not whatever. In science, we assume the null hypothesis to be true until we have enough evidence that suggests otherwise, right? So we believe that depth of processing matters, right? The levels of processing. We believe that that works because we have a lot of evidence supporting it, right? But until we have that evidence, we assume that it doesn't really matter. Okay, so the null hypothesis when testing psychic abilities is that you guys don't have it. All right, so let's flip the coin. I'm going to flip the coin. If any of you guys are psychic, you have the potential to win some money. The most psychic person will win 5 liras. Okay, those of you, actually everyone stand up. This will be easier. Alright, if you think it's going to be heads, I want you to raise your hand. Alright? So there's a signal maybe out there, a signal of the future, what it's going to be. So if you detect the signal, raise your hand. Or, you know, just guessing, right? Because you can guess. So is it going to be heads or not? Raise your hand if you think it's going to be heads. What is it?
Heads.
It's heads. Everyone who didn't raise their hands, sit down. Holy cow! We have about half of you are psychic. Right? So, some of you guys got it. Are they psychic? Are these people psychic? He says, I cannot say. I like that. I like that. There's a 50% chance of getting it right, right? A 0.5 probability of getting it right. That means that half of you should have got it right, and about half of you did.
Well, how did you know it's going to be head?
I didn't know it was going to be head. Oh no, I'm psychic. I made this beforehand. Whatever. Okay. So there's a 50% chance of getting it right. There is a 1 probability or 100% chance of getting a result that is this extreme due to chance. You guys can sit down for a minute because we're going to talk for a minute about what this means. But remember who you are. You might want to win 5 liras. Okay, there's a 100% probability of getting a result that extreme. That extreme. What does that mean? There's a 100% chance of getting something that extreme right. Or of getting a result that's extreme. This is a p-value. When there's a question on the study guide about what the p-value is, this is it. It's the probability of getting a result that extreme just due to chance alone. So, this or more extreme, what does that mean? Think about it. If I flip the coin 1 time and you get it right, that's just as extreme as getting it wrong. Does that make sense or not? You had an equal probability of getting it right as you did wrong, right? So they're both equally extreme.
Yes.
Okay? Maybe this will make a little more sense when I do the next thing. Okay, up! Those of you who got it right, we're going to flip again, and we're going to see if I'm psychic. Okay, if you think it's going to be heads, raise your hand. It's tails. If you raise your hand, sit down. Holy cow, I'm psychic. You guys are psychic. Right? OMG! What are the odds that they would get this right? What are the odds that they would get 2 in a row correct? What's the probability? What's the chance that they would get 2 in a row correct? Anyone know the basic laws of probability? You're gonna, yeah, it's 25%, right? You multiply the 0.5 and you did it again, so you multiply it by another 0.5. So getting 2 right in a row, 0.5 times 0.5 equals 0.25. That's a 0.25 probability, or 25% chance that you guys will get it. And look, holy cow, we have about 25% of the class standing. Now, what's the probability of getting something this or more extreme? Well, the probability of getting 2 right in a row is just as extreme as getting the 2 wrong in a row. Does that make sense? So to find out the p-value, which is the probability of getting a result that extreme just due to chance, we just add these two probabilities together. So 0.25 plus 0.25 equals 0.5. So this is a 50% probability of getting a result this extreme. Okay? All right. Should I flip again? All right. Raise your hand if you think it's going to be heads. It's heads. Okay, those of you who raised your hand remain standing. How many flips was that? That was 3.
I'm negative. Here,
Raise your hand if you think it's going to be heads. It's heads. Sit down. You guys keep going. That's 4. Holy crap-a-moly! That's 2. Are they psychic? Let's do it again. Raise your hand if you think it's going to be heads.
Tail.
Tail. Oh. That's 5.
Is everyone remaining?
Yeah, you're not done yet. Raise your hand if you think it's going to be tails.
Heads.
Oh. You got it, man.
You got it. You got it.
You got 6 right in a row. You stand up, you're still right. Raise your hand if you think it's going to be heads.
Heads.
Oh! So, was he right often enough for me to give him the 5 errors?
Yeah,
6 times?
6 times? So when is enough, right? I mean, I do this one time and it's like, no, you know, they're not psychic. They just got lucky one time. You do it 2 times, they just got it 2 times. How many times do we have to have them get it right in order to say, yeah, okay, maybe they're psychic? Or, yeah, I'm guessing they're psychic. 5 is pretty good. But if you have a lot of people, you're going to get, you know, some people that get 5, right? So, traditionally, in science, when P is less than 0.05, that's when the probability of observing an event that extreme, or more extreme actually, we can tag that on too, that or more extreme is less than 5%, we say, okay, we're going to say that something's there. We're going to reject the null hypothesis. Why not P is less than 0.0463, or P is less than 10, or P is less than 2? Huh, great. I really don't know why 5 was selected. It's a nice round number. 5, it's easy. You don't have to go out to multiple decimal points like you do with something like pi. You know, when the probability is less than pi, it's significant. Oh man. I don't know. Someone was biased and they picked 0.05 and a lot of people agreed with it. But depending on individual scientists' biases and individual disciplines' biases, researchers might use different values. So for some research, they want it to be less than 0.01, or some even less than 0.001. For people who do research that isn't as well respected, they might use P is less than 0.1. Okay, 6 in a row is enough. So, Sunday. Here's your 5 errors. Don't use it all in one place. So the probability of getting 6 in a row correct is 0.5 times 0.5. You do this 6 times. And that's 0.15625. Okay? Now, the probability of getting a result that's that extreme is the probability of getting 6 in a row correct or 6 in a row wrong, right? So actually, I should have had all of you people who were sitting down keep guessing, because maybe some of you would have guessed wrong every single time, right? Which would actually suggest that you're psychic too. It would suggest that you're a confused psychic, but you're still psychic, right? Now, some of you might have a problem with this, you know, saying that, okay, 6 was enough. I went out to 7, but if we had stopped at 6, he would have got it, right? So is 6 really enough? flipping coins is really easy and cheap, right? I can do this fast. I can do one coin flip every maybe 2 seconds. It doesn't really cost that much money. Imagine that I get paid, 10 liras an hour to flip coins. So flipping a coin for an extra 2 seconds is going to be a couple kurush, maybe, no big deal, right? Really cheap. Longer tests with this coin flipping is fairly inexpensive. My cost, if I do 1 hour flipping versus 2 hour flipping, I go from 10 to 20 liras. No big deal. And by doing more flips, I have a better chance to uncover the truth, right? Because it's still possible that he just got it right due to chance, right? We said that there was less than a 5% chance that we would see something that extreme. But still, if we flip a lot more, we can get that p-value down farther. We're talking about uncovering the truth in science. We talk about making type 1 or type 2 errors. So type 1 or type 2 errors are when you get it wrong. A type 2 error is when you say that there's nothing there, but there actually is. So what is this like in signal detection terms? Is this a false alarm or a miss? Yeah, it's a miss. There's something there and you missed it. A type 1 error is when you say that there's something there, but it really wasn't. So I said, he's psychic, so I give him my money. This is what people do with investment bankers, right? You're going to invest my money in the stocks that you think are going to be good, right? I'm giving you my money. So we can make these type of errors in science. And by making more and more observations, we decrease the likelihood that we will get these errors. So do they have to get 6 in a row? Not necessarily. If we use the p is less than 0.05 criterion and we only flip 6 times, yeah, they have to get all 6 in a row. But if we're willing to flip a lot more times, they don't have to necessarily get 6 in a row. So if we flip more than 6 times, all they have to do is get 8 out of 9 right. They could get the first 4 right, and then the middle one wrong, and then the next 4 right, and they're still demonstrating some evidence of psychic. But wait, can a psychic ever miss? What's the difference between a prophet and a psychic? The prophet's never wrong. So he's not a prophet, he got one wrong. Maybe he's a psychic, right? So psychics claim to be sensitive to the unseen. There are 2 non-random things that affect responding, right? We have bias and sensitivity. If there's no sensitivity, only bias is going to affect responses. So in the long run, for a non-psychic with a fair coin, they should have their hits equal their false alarms and their misses equal their correct rejections, right? If I'm always saying yes, it's a head, and it comes up heads 50% of the time, what's my hit rate? 50%, right? I'm saying every time it's heads, so I'm going to get it right half the time. What's the percent of the time that I'm getting false alarms? 50%. So my hits and my false alarms will be identical, right? If I'm not sensitive at all, then I'm only biased. So if these differ more than what would be expected by chance, we reject the null hypothesis because the evidence is consistent with the belief that the person is psychic. All right, I'm going to stop here, and next class we're going to talk about how we measure things. How we measure happiness and love and all that other good stuff. See you next class.